This is Module 2, Lesson 2, and the topic is measures of center. Average, which is what we typically think about when we think about measures of center. Average, when you stop to think about it, is a funny concept. Although it describes all of us, it describes none of us. While none of us want to be the average American, we all want to know about him or her. That's a quote from American Averages written in 1980 by Mike Feinsilber and William Mead. More recently, Tom Corley, a CNBC contributor, describes the average American this way. The average American makes $735 per week, spends $69 per day, has $34 in their pocket, is 17 pounds overweight, but only exercises 17 minutes per day. The average American reads 4 books per year while watching 33 hours of TV per week. That's 1,716 hours per year. The average American spends 116 minutes per day on social media and 5 hours per day on a cell phone. Works 34.3 hours per week, makes about $48,000 per year, and has less than $1,000 in savings. Statistically, the word average is somewhat ambiguous because there are different methods for actually calculating the average. But loosely stated, the average means or represents the center of the distribution or the most typical case. We're going to focus on 3 measures of center. I like to call them the M&Ms. They each start with the letter M: mean, median, and mode. A couple of things to recall from earlier lessons in Module 1. Remember, the population consists of all the subjects that are being studied. That's the big picture group. Whereas a sample is a subgroup or that is taken from that population. And connected to each of those is a parameter or a statistic. The parameter is a characteristic or numerical measurement obtained using data values from the population. Remember, they both start with P, population parameter. One of the new things you need to know is that statistically we represent a population parameter using Greek letters. Statistic is that characteristic or numerical measurements that's related to the sample. Again, remember they both start with S. Sample, statistic. And for the sample, we use Roman or traditional English letters to represent the various statistics. So let's meet the M&Ms. The measure of center is the data value or possibly values at the center or the middle of a data set. We're going to look at the definition, the formula, the advantages, the disadvantages, some of the properties and uses for each of the measures of the center: mean, median, and mode. I'm also going to show you how to use the technology to calculate these. Nobody, no statistician, no researcher performs these calculations by hand anymore, since we have access to technology such as the TI-83 or 84 calculator or possibly a free website. We're going to forego the use of Excel because there is an issue with it in relationship to a Mac computer. So the mean is what most people think of when they hear the word average. It's found by adding the data values up and dividing by the total number that you have. The mean is the most important of all numerical measurements used to describe the data because it takes into consideration all of the data values. So if you're ever limited on the ones you can calculate, you definitely want to calculate the mean of the data set. The mean is unique to the data set, and it may not necessarily be one of the data values that you have listed. Some of the challenges related to the mean is that it's affected by extremely high or low values, what we call outliers, and it may not be the best measurement to use if you have those outliers. One of the reasons that the mean is so important is that it's used in calculating other values, and it's going to vary less when the mean or when the samples are taken from the same population and you calculate all three of the values. You're going to have that consistency. Okay, this is the formula. Again, please do not get bent out of shape about the formula, okay? But mathematically, what you're doing is you're adding up all of your data values and dividing by how many you have. And we just use fancy math symbols to show that. The big E looking symbol called sigma means mathematically to add them all up. So this just tells me add up all of the values and divide by the sample size. The one symbol you do need to know is this one right here, the X with the line over it. It's read as X bar, and it is the mathematical symbol for the sample mean. The other symbol you need to be familiar with is this funky looking U symbol. That's the Greek letter mu, and it represents the mean of the population. You will see those in questions that you have or in problems or in research, so you want to be familiar with those two symbols. The median is the middle value of your raw data when they're arranged from smallest to largest. So this is one where the stem and leaf plot might come into play because you have the data ordered on the stem and leaf plot, and you simply need to find the value that is in the middle. The median is used when you want to determine the values that fall in the upper half or the lower half of the distribution. It's not affected by the outliers. So if you have outliers, perhaps the median is the better option in terms of the measure of center. It can be one of your original data values, but it does not have to be. It has different notations, again, depending upon the technology that you're using. Some technology label it with MD. Some use MED, the first three letters of median. Or sometimes you'll see it written X with this little wavy line across the top. It's called a tilde, and it's read X tilde. The median, finding the median depends upon how many data values you have. You want to put them in order and then find the value that's in the middle. Well, that's easy to do if you have an odd number because you have an exact middle. If you have an even number of data values, then you actually have two middles, and we actually find the mean, or what you would call the average, of those two middles. The mode is the data value that occurs the most often. It's sometimes referred to as the most typical case. It's very easy to compute because all you're looking for is what data value or possibly values occur the most. This is the only measure of center that can be used with qualitative data, specifically at the nominal level. It's not necessarily unique to the data set because you can have more than one mode, or it is possible you don't have a mode or a value that occurs the most often in the data set. It doesn't really have a special symbol, and you just basically have to scan the list. From a quantitative standpoint, you can again use the stem and leaf to help you identify the mode. So a lot of students say, well, which one should I use? Well, unfortunately, there's not a single best answer to that question. There really are no special criteria for determining which of the measures of center would be best. Oftentimes you want to use, if you're writing up your research, you want to avoid using the word average. Instead, be specific. Say the mean, the median, the mode. And you can use the advantages and disadvantages that we looked at above to make a decision on which one you think you should use. Again, remember, if you're limited on what you can calculate, you definitely want to calculate the mean, because the mean takes all of the data values into consideration and is actually used in other statistical calculations. Let's take a look at some connections between the measures of center and trying to identify the distribution. We talked about distributions earlier, and we were doing it basically using our eyeballs or kind of our gut, just looking at a visual representation. But we can actually verify whether or not a distribution is skewed to the left, skewed to the right, or symmetric by comparing the mean, the median, and the mode. So if you'll recall, a bell-shaped distribution is symmetric, which means the left side mirrors the right side. The data values are evenly distributed. It is what we call unimodal. It has a single peak and a single mode. And if you perform the calculations and find that your mean and your median and your mode are all virtually the same value, that is how we can confirm and verify that the distribution is symmetric. When you think about it being right skewed, remember, right skewed means the majority of the data values are on the low end, and then it tapers off as you move to the right. In this relationship, to confirm that it is right skewed or skewed to the right, the relationship is that the mode is less than or smaller than the median, which is then less than or smaller than the mean. You can see that relationship right here. You want to make sure that this relationship, the mode is less than the median, less than the mean, is a true statement. Finally, to see or confirm that a distribution is left skewed, you look at the relationship that the mean is the smallest. So the mean is less than the median, which is less than the mode. So you'd be looking for this relationship here, and you want to make sure that that's a true statement. Now, sometimes the mode, because especially if you have more than one mode, can kind of cause a problem when you're looking at that relationship. So you really, most of the time, you can focus primarily on the relationship between the mean and the median. In another PowerPoint and video, we're going to look at an example of how to use the different technology to calculate the measures of center. But the neat thing about the technology is that it actually calculates all of your descriptive statistics at once. And so I want us to continue looking at the other measures of variation and measures of position before we actually look at how to use the technology, because it would give you some information you wouldn't understand.